Alright, hi everyone. So this is probably the most important video I've had to make, so I had to really think about how to do it. So hopefully you're ready to tune in, maybe even take some notes, but definitely be listening and rewind if you get caught on a part where you're not understanding. Okay, because like I said, this is going to be an important video. I'm going to try to tie all this together. So for me, I need to understand what is going on with the topic totally, and then you can zoom back in on the fine stuff. It really helps me to understand. So I'm going to really go through this. So we're going to be learning about, so we are on this part here, the this graphing linear equations with slope-intercept form. That's what we're going to be talking about. Before we do that, I want to talk about a couple things. Number one, we are doing linear equations. Linear, okay? And what that means is it's in the form of y equals x. Okay, so x to the first power. And y is to the first power. Okay, now because we have a y-axis and an x-axis in all of these, we're pretty much going to be seeing, especially this year, we're going to be seeing basically y and x as our two variables. And all we're going to be working with this year is the y and x to the first power. Just so you know, that's what creates this line. Okay, so you can see that this y to the first power x equals x, something x to the first power creates a line. Whereas you can see here, in the next one over, that this would actually be y is equal, this would be a y value of to the first power, but this is when your x is squared, and then this would be when your x is cubed. So you get these different shapes. So this is not a line, this is called a parabola, and I don't think this thing has a name, but this is what y to the third power ends up looking like. It comes all the way to the center and then goes back out. Anyway, my whole point is, I want you to understand that we are talking about linear. Okay, so we're talking about linear. So what we've done is we've learned that we're going to graph linear equations, and the way we've done that is we've created the x, y, we've created the table of values. Whoa, that was wild. We've created the table of values where the equation goes in the center, we pick a couple values, and this is basically what, so I input an x, and that gives me this output of y. So if I make x 0, then y equals 3 times 0, which is 0, plus 2, which is 2. So I get the 0, 2, and that's just, and you guys have already done that. So then we learn that this beginning part right here is our slope. Okay, I don't know if you actually understood that, but when it's in this form, which we're going to talk about today, the slope m is y2 minus y1 over x2 minus x1, also known as rise over run. Okay, the change in the rise over the change in the run. And then we did proportional relationships, which I could almost skip because I don't believe that they belong. I guess I can see how they belong, but they're kind of unnecessary in this chapter. Okay, so yes, we'll talk about that. Okay, so now we're going to talk about what is this slope-intercept form. Okay, we're going to talk about what that is, and this is slope-intercept form, so you definitely want to write that down. And m is the same as this, so m is slope, and b is what we're going to call the intercept, so slope-intercept is the y-intercept, and we'll look at that closer in a second. Okay, so as you can see, this is what they want to introduce you with. So this, and I don't really love this, which is why I started with my own kind of idea there. Okay, so the intercept they're talking about is y. So don't get confused. This is the y-axis. this is the y-intercept. It intercepts y here. The x-intercept, we aren't even going to talk about. Okay, the only thing I need you to know about that is if you graph this thing using this form, and it comes down to a specific number and it asks you what is the x-intercept, well, it's easy to tell that the x-intercept is this value, whatever this value of a is, call it 5. So if they said graph this and then it graphed and then what is this value, it would be this, whatever a was, would be your value. But for the purposes of learning slope-intercept form, this is it. Y equals mx plus b, where m is slope and b is where it intercepts the vertical line. Okay, so now, and we already kind of talked about this, but just remember the sun rises. I kind of like this graphic because rise, when we're talking about slope, rise is think of the sun going up and down in the sky. Rise over run. Somebody runs horizontally unless they're super extreme. They definitely don't run vertically. So yeah, the rise is the y's and the x's are the run. So if you want to look at it, so basically what they're saying is she went up 3, so she rose 3 and to the right 6, so her slope is 1/2. So you can see that slope is 1/2, and it went through the y-axis at -1 here, if you can see my laser. That's -1, so the y-intercept is just -1. Okay? So, or plus a -1, but we know that plus a minus is just minus. So the simplified version of that is this. So let's look at some of these. Okay, I'm not going to graph these. Yeah, actually I am. Let's graph these. So we have, I just want you to see some of the differences here. So we have y equals 1/2 x minus 3. Okay, so minus 3 means I start my first one at a y-intercept of -3, and then 1/2 means 1/2 is, because it's positive, is up 1 and right 2, because it's rise over run, right? So I'm going to go up 1 and right 2. Up 1, right 2. And now if I could draw, dare I try this straight line thingy? Oh, that's not looking good. Nope. Nope. Okay. Now if I draw a line through it, that's approximately my graph. Okay? So now, this one to the right, I have a -4. So I come here to -4. That is my y-intercept. And now I have -4 over 9. I can pick where my 9 goes, or my negative goes, it doesn't matter. But this means I'm going to go down 4 and right 9. Down 4, 1, 2, 3, 4, right 9. 1, 2, 3, 4, right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, or I could go, or I could switch this and say +4 over -9. Okay, all I did, because remember, if both of these numbers were negative, it would be positive, so it can go in either one, and this would be up 4 and left 9. So let's go back to our spot, our y-intercept, and go up 4, 1, 2, 3, 4, and left 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. See how both of those worked? Rewind that if you didn't get that, and that was a terrible draw through the lines, but that would be on a straight line. Okay, now let's, oh, it wouldn't stop moving a second ago, and now it, there we go. Okay, so now we have, I'm going to do these a little faster, because I can already see you guys complaining about how long this one is. Okay, so +9 is my y-intercept, and I have the slope of 9 over 7, which means I'm supposed to go up 9 and down 7, which is pretty much impossible to do with this graph. So I'm going to change these both to negative because that's the same thing. So I'm going to go right, because a negative divided by a negative is positive, so I didn't change anything. So I'm going to go down 9 and right or sorry, down 9 and left 7. So it looks like my graph's going to be way off the graph. I didn't do a very good job on this one. So here I have an 8, and then I'm going to go down 8 and right 7. So this is approximately my graph on this last one. Okay, so what do I want you guys to notice? Okay, notice here that this is a positive slope, and from left to right, it goes up. This is a negative slope. From left to right, it goes downhill. Okay? This one here is a positive slope. From left to right, it goes up. This is a negative slope. From left to right, it goes down. Okay, so you need to be expecting that. If you have a negative slope and your line goes this way, you did something wrong. Okay, so hope sense. And then so we've noticed. So here's the one thing I want to say about proportional relationships. I don't really care about this part of the chapter that much, other than to say, if you guys remember when we did ratio tables, right? We had like a value of 2, 4, and then this would be 4, 4, 8, right? And then the next one would be 6. I'm trying to do this one as easy as possible. 12, right? So basically what you realize is that the constant of proportionality is this times 2. And then this one was times 2. The constant proportionality was 2 over 1. And that is your slope. Okay? So if you notice, so y equals mx plus b is what we're supposed to be doing. But in a proportional relationship, it always starts at the origin. That's what makes it proportional. So think of an hourly worker who makes $8 an hour. And that's it. Like, so every hour he works is equal to $15 an hour. So if he works 1 hour, it's $15. If he works 2 hours, it's $30 an hour. If he works 0 hours, it's $0 an hour. Okay? So think about it. What is the y-intercept here? The y-intercept is 0. So if instead of putting plus 0, y equals mx plus 0, we just get rid of it. So that's the only thing you need to know about proportional. So really you're getting 2 lessons in one here. It'll ask you questions, is this a proportional relationship? And the answer is no if it starts anywhere except for 0, 0. So it's really that simple. And what you need to understand is if it starts at 0, 0, there is no plus b. So slope intercept y equals mx plus b is unnecessary. That's all I want you to get from that. And then I want you to see, so this is back to the y equals mx plus b. I want you to see an example, okay? The cost in taking a taxi in x miles is represented by the equation y equals 2.5x plus 2. Okay, so y equals 2.5x plus 2. The only thing I want you to see out of this is that your slope is the rate. Okay, it's the rate. It's how much it is per mile. This extras is how much it costs for you to get into the cab. Okay, so if I took away the slope, right, if it was just $2, then if I took away the rate and all I did was get in the cab and get right back out of the cab, then it would just be y equals 2, and my graph would just be at 2, 1, 2, and it would go across. Like, I owed $2, no matter how much I got out of the cab. But this 2.5 is this rate. All right, so when you think of slope, slope is also the unit rate or rate of change. All right, now if it's growing, it's a positive. So if it's a charge, or if my thing is growing, it's going to go left to right, because then let's consider this as time, right, over money, for instance. So as time increases, then this would be at something where it's growing. So it might be my charge here. There wouldn't be anything in the negative category, right? This would be at 2. It cost me $2 regardless. So I can graph this at $2, and then as time goes on, the amount of money I owe him goes up. So anyway, I just wanted you to understand that. I don't even know what this question wanted, but again, if I get out of the cab, it's $2. After that, it is $2.50, 2.5, or another way of looking at that would be 3 halves. No, that'd be 1.5. 2.5 would be 7 halves. No, 5 halves. 5 halves. So that would be your slope. So it'd be up 5, right 2. Anyway, hopefully that didn't hurt at the end. I feel like that was okay. I hope this helps. So we're gonna continue on this. There's other forms that we can put it in besides y equals mx plus b, right? Because we don't always know from an equation what this what slope, where it goes through the y-axis. So sometimes we have to solve for that. Sometimes they just give us a point and a slope, and we can solve for that as well. So anyway, hopefully this wasn't too long. I know it was, but I highly recommend you watch it again even, or find another video that of a teacher that you like, Khan Academy or something. I guarantee you his are longer. But yeah, y equals mx plus b. It's one of the most, you'll be hearing it for years to come. This is slope-intercept form. Thanks. See you later.